Now, largest element in the array. So you know that this is very easy to find out the largest element from an array. Now this is the array a1, a2, a3, a4, dot n elements are there. It may be 2, it may be 100, it may be 5 minus 8, like this. Okay, so these are the numbers, and you have to find out the largest element. Now you know that similarly smallest element also can be find out. How? The reason logic you know already, that I will compare, means I will take this as the first one as the smallest largest element a1, then I will compare with the second element with the largest. If it is largest, if second element is the larger than the largest element that I have assumed, then I will swap. Okay, you know all this. Okay, so now am I sure? No, all of you know that how to find out the largest element. Yes.
Yes, sir.
Okay, so this is very easy. Now suppose one of your friend uh, thinks that I should try to improve the time complexity for this. You are saying that it is so. How much time it takes? How much time is, how many comparisons are required for this? If there are n elements,
Sir, in comparison, sir.
n comparisons. Anybody else? How many comparisons are required? Comparisons between the elements to find out the largest. Okay, if there are two elements, do you need two comparisons?
No, sir, one.
So if there are n,
N minus one, sir. Sorry, sir.
Sir,
Sir,
n
N minus
minus
one, sir.
one.
n minus 1. Now you are thinking that that you will improve the time complexity. That means you will reduce the number of comparisons. Okay, let us try. So suppose you are thinking that it may be like this. Say these are the elements a1, a2, a3, in this way. Now what you will do? Now your friend is will compare these two. Okay, these two elements, and whichever is larger, larger will be put here. Similarly, he will compare the next two element in this way. Means if he tries to reduce the time complexity like this, say in this way, he will compare. Now again he will compare. See, you say it is 2, it is 8, so you have put it 8 here. Similarly, it may be 3 here, 10, so you will put 10 here. Now to find out the largest, then these two elements also should be compared. So again you are comparing. I am drawing an edge like this to indicate that these two elements are compared, 8 and 10. So in this way, you will do for all others. Clear? And again, these elements are to be compared. Otherwise, I will not get which is the smallest. So in this way, if you means again, if you do like this, okay. So similarly here also you will do like this. In this way, you will get finally, say here, I am not drawing the complete, but you see the number of nodes are reduced. This intermediate node is reduced in each level. So what I am getting? I am getting what structure? Tell me. This will be the
Sir,
name of this
binary tree. Sir, binary tree, sir.
binary tree. You are getting a tree. Now, how many comparisons are there? You see here. This here you are comparing these two elements. Clear? In this case also you are comparing these two elements. In this here also you are comparing this. So you see these and these elements are compared, these and these elements are compared, these and these elements are compared. Now can you tell me, means even if you have tried to design a new algorithm like this, how many comparisons will be there? See, how many edges are there? Tell me. You know,
Sir,
if
n
there,
log n, sir. It would
you
be
know,
n log n.
no,
Order
you
of
know
n.
that in a binary tree, if there are n number of leaf nodes, then how many edges are there?
N minus one, sir.
n minus 1. I
Minus
think
one,
you
sir.
know the proof from the data structures. Clear?
Yes, sir.
So every node has, that means actually you can think this binary tree as an inverted binary tree. Okay, inverted binary tree. If you invert this, the whole structure, then you will get a tree. If you invert the entire these structures, then you will get a tree like this. Okay. Now you know, if there are n number of leaf nodes, then there will be n minus 1 number of edges. The proof is simple. Every node has an parent except the parent, except the root node. Root has no parent. So total n minus 1 edges are there. Now, so therefore n minus 1 edges are there. Is it possible to draw, you connect all these using less number of edges? You see, this is a connected graph. You check it. Is it possible to draw a graph that will connect all these nodes using less than n minus 1 edges? Means tree, is it possible to draw? No, it's not possible. Then these will be disconnected. There will be at least two components. But I know, to find out the largest element, I should have a connected component. If the component graph is not connected, then we cannot uh, guarantee that this will be the largest. So that means the basic simple structure is a leaf, sorry, a tree, binary tree, and in this case n minus 1 edges are there. Now each edge, each edge corresponds to compare, that you are comparing the elements, so comparisons. So basically this is comparisons between two elements, comparisons between two elements or two numbers, whatever you say. So that means what? At least whatever be the design of your algorithm, there will be at least n minus 1 comparisons will be required. N minus comparisons, 1 comparisons will be required. Okay, to find out the largest element. So this is called lower bound. So if anybody asks you that how can you say that it is not possible to design any log n algorithm, you just say that whatever be the techniques, you are just comparing and you will get a structure, graph like structure, and you cannot have less than n minus 1 edges, because if you would like to uh, mm, uh, get a structure, graph structure which has less than n minus 1 edges, then that graph will be disconnected. And if the graph is disconnected, then all the elements, it is not possible to means, if suppose there are two components, for example you are getting two component in the graphs like this, so you are finding out the largest here, but how can you compare these two? If you would like to compare these two, then they should be connected, otherwise it's not possible. So that means the lower bound to find out the largest element will be this. It will take at least, so you see, I am not using big omega, big omega n time, big omega m time. That means this is the lower bound. Nobody can improve than this. Is it clear? Now, next problem. Say, problem. Next problem is that find out largest and smallest element in an array. So now tell me how many number of comparisons to find largest. It will be how much? Tell me.
Sir, n minus 1 again.
Yes.
And this one, smallest.
So smallest will also be n minus 1 if I'm not wrong.
Okay, you are not wrong. Fine. N minus 1. Fine. Anybody? Is it possible to improve slight? N minus 1 comparisons are required or not?
So
See, n
we can
minus 2.
combine both largest and
Sir, if
smallest
we are
in
finding the largest element and we can store the smallest element in a variable and we can just update it while finding the largest element as well at the same time.
See, but I am asking about the number of comparisons. See, whenever you are getting the largest, you are sure that that will not be the smallest. So no need to compare with it. So the number of comparisons to find out the smallest will be n minus 2. Am I clear? Very
Yes, sir.
simple. So total number of comparisons is n minus 1 plus n minus 2. That will be equal to twice n minus 3. Now, this is the, this technique how to find out. Now let us try to improve. So you are trying to improve. How can we improve? Say, suppose this is the array. Now in this array, all the elements are there. Now what you are doing, you will partition this array into half of the size. Say n by 2 here, n by 2 approx. N by 2 elements are here. Now what you will do, you find out the largest and smallest from this portion. You find out largest and smallest from this section. Or you can say that this is the array, means A, and this is the B. Now, how can I find out the largest from this and smallest from this? I will recursively decompose it again. Say again, you will decompose it, the array A, into two parts, and go on dividing until and unless in the sections there are two elements. Now you see, if there are two elements, you can just compare which one is the larger and which one is the smaller by only one comparison. Anyway, now you will merge the solution. Suppose you have obtained which is the please mute. You have obtained the largest and smallest. So from this you have obtained this one as the largest, LA, and this one is the smallest, SA. And in this section, this is the largest in array B and this is the smallest in array B. The two elements you have obtained in these two partitions. This is the largest, one will be the largest from this, and one is the smallest. These are largest and smallest. Now tell me, if you have solved the two sub problems of n by 2 in this size, now how can you find out what will be the largest element in the whole
Sir,
array?
compare LA and LB.
Right.
Compare SA and SB. It's for
You
smallest.
compare LA and LB, and you compare SA and SB. You see, one of the two larger element will be the largest and one of the two smaller element will be the smallest. Clear? So so this is L and this is S. Now let us check how much time will be required. Is it clear? It is just like recursion. I am finding out the largest, smallest in this partition, largest, smallest in this partition. Now, how to find out the largest, smallest in this partition? Again, you divide. I am not showing this in the diagram. Again, you divide. Clear? Now, basically, the figure is like this. You divide it into again two part, two part. Again, you go on dividing. Again, you go on dividing like this. Until and unless there are only two elements. Now, we are worried about the time complexity. So, let Tn be the running time complexity. to find the largest and smallest in the array. Please remember that you should always write what do you mean by Tn with respect to any algorithm. So I will not write like this every time. I since this is the first time I am showing you writing that let Tn be the running time complexity to find this, but you should write always. So now you tell me if Tn be the running time complexity. Please mute. Please mute. I am requesting. Yeah. So let Tn be the running time complexity. Now, what is the running time complexity to find out the largest in an array? Here you may write also in array of size n. So what we are doing? We are solving this problem. We are dividing this problem into two sub problem of size n by 2 n by 2. Okay. Don't worry. You may think that if the total number of element is odd, then here will be n by 2, here will be n by 2 plus 1. But you see, n by 2 or n by 2 plus 1, that does not matter, means too much. Okay. Because the order, we are worried about the time complexity mainly. Now here you can, here you assume that, okay, I am coming that what is the assumption. But here you see, can I write it Tn by 2 plus Tn by 2 plus 2? See, Tn is the running time complexity to find out the largest and the smallest in the array of size n. So now I am finding out the largest, and to solve this, what I am doing, I am finding out the largest and smallest in partition A of size n by 2. So that time will be Tn by 2. Similarly, to find the largest and smallest in array of size B, in array B of size n by 2, it will also Tn by 2. Clear? And plus 2. Why plus 2? Because you see, in this case, you are comparing these two elements. So this is one comparisons and this is another comparisons. So plus 2. Clear? So that means, or we can say that Tn is twice of Tn by 2 plus 2. When it is true, if n is greater than 2. But if n is equal to 2, how many comparisons are required? If n is equal to 2, is it clear? Which one is the larger? You can find out if there are only two elements. Now you need to solve it. You need to solve it. So how can you solve? Is it clear? Tell me up to this. Hello.
Yes, sir. Yes, sir.
Now I am going to the solution. So this is called the recurrence. Actually, now we need to solve it. This is the equation, recurrence sequence. Now we will solve it. How? So here you see that just here Tn is 2n by 2 plus 2, and this is the terminating condition. Okay, means when it will terminate. So here you see I can write Tn equal to twice of, you expand it. I can write what? Tn is 2 Tn by 2 plus 2. So Tn by 2. So this Tn by 2 can be written as, you tell me. Can I write this?
Yes, sir.
So basically this is 2 square T n by 2 square plus 2 square plus 2. Then if you again expand it, it will be like this. I am writing this as like 2 plus 2 square. Okay? So in this way, it will go on. Okay, and finally it will be say 2 to the power I. General term I am writing Tn by 2 to the power I plus 2 plus 2 square plus 2 cube. Yes. Now you see, we need to find out the closed form, not recurrence. Means actually what should be the value for this. So here you see, when it terminates, the terminating condition is that if n equal to 2, then t2 will be 1. So here also, so therefore I need to apply this, that this will terminate when if tn by 2 to the power I, this should be 2. You check, because what we know, t2 is 1. So if you put this equal to 2, then this portion will terminate. Means it will be, there will be no term involving t. Fine. So if this is 2, then this will be 1. I know. Now this becomes, or I can say this becomes 2 when I can write 2 to the power I is say n by 2. Clear? Or I is log n by 2. That we can write. Now here you solve, means find out the solution final. So here solution will be what? This is 2 to the power I is, you know, n by 2, that you know. And this is t of 2. And this is what? This portion is, you check, 2 plus 2 plus 2, this sum. This is what? This is which series? This series is, tell me.
GP.
Sir, geometric progression.
GP, sir.
With first term is 2 and common ratio is 2. So here this will be 2 into 2 to the power I minus 1 by 2 minus 1. That you know. A into r to the power n minus 1 by this. So basically it will be n by 2 into t2 is 1, you know already. And this is what? 2 into 2 to the power is I is n by 2, you know. This at 2 minus 1 is 2. So this will be n by 2 plus n, this portion, minus 2. So that is equal to what? 3n by 2 minus 2. So that means we are getting finally Tn is it improvement? What was in earlier case? What was the Tn? Sorry.
Sir, n minus 1.
No, and not n minus 1.
Yes, sir.
2n minus 3.
2n minus 3, sorry. 2n minus 3.
2n minus 3. Okay. So now check, and in this case it is 3n, means, see, you can see 2n minus 3, 2n minus means n plus n, and here n plus n by 2. Forget about the this constant part, because this does not affect too much. So this is improved or not, you check it. If n is say 1000, which value will be larger, this one or the previous one? 2n minus 3 or this one? The previous one will be the larger, and in this case this will be the smaller. Is it okay? So time is reduced. You see, the order of time complexity is not reduced. In both the cases, the time complexity is big or open. In both the cases, here as well as the previous algorithm. But in this case, you check this constant part. Due to this constant part, this is smaller than the previous case. Previous case 2, it was 2, so it will be faster than the previous one. Clear? So that's why if you design any, sometimes it the constant part is also a factor. Okay, that some algorithm exist and you have reduced that, you are not able to reduce the time complexity, but you have reduced the constant factor to. So if it is so, if you can reduce the time, constant time to a low value, then your paper will be accepted. So don't think that always we will try to reduce the time complexity, but also take care of the constant factor.
Sir,
Now,
but both are big of n. No, sir.
we go open. Okay, but which is the faster? Say in this case, for example, if you are finding out the smallest, largest and smallest of say 100, n equal to 100. Say suppose I'm taking small value. So in this case, here it will be Tn will be how much? 150 minus 2. And in that case, in earlier case, it was Tn was 2n minus 3. 2n means 200 minus 3. So which is faster? This one is faster. And you, if you take n very large, not only, then you check, this will matter. So that's why I'm saying still this is better than the previous one. Okay. Now suppose next problem 3, that find largest and second largest element in an array of size n. So you can apply the same strategy just like the before. Okay. Means largest and second largest means largest, you know, n minus 1 comparison, and second largest means it is smaller than the largest but larger than the remaining elements. So you can apply the previous algorithm, or you can apply means partition 2n minus 3 like that. But I want to improve further. How can we improve? So here I am showing you. Suppose these are the elements in this way. Now what you will do, you compare. So you these are the all the elements, say a1, a2, a3, a4, in this way all the elements. And in the previous case, just a minute, I forgot one point. You assume that n is power of 2. Okay, n by, here I told na, n by 2 to the power I is 2. So n 2 to the power I is n by 2. This n is power of 2. It will be. It is just for calculation. It doesn't matter the order of time complexity. Now here you see a1, a2, a3. Now how can you? So what we will do? See, I have to find out the largest and the smallest, second largest. So if I put the larger of these two, suppose it is 4 and it is 8. So it will be 8. Clear? Next, you are comparing these two. Suppose it is 9 and it is say 3. So you will put here 9. In this way, you keep. Again, you compare these two. Again, you will compare these two here, this side, in this way, and put the larger here. Put the larger here. In this way, you will get the larger of this, largest of all the elements at the top of the root. Is it clear?
Sure.
Now, so largest will occur at the top here. This will be the largest. Now my question is, I have to find out the second largest. Can anyone tell how can I means one trick is there? How can I find out the second largest?
So just compare the second two nodes and get them.
My drawing is not okay. I am just redrawing it again. Here you check just like this. So I'm it can be extended more, but I am drawing here. Okay. So in this way, suppose this is 100 and this is the largest, and 100 wheels occurring here. So here you see these 100 occurs this also here when it was compared with suppose 90, and say it is suppose 80. So 100 occurs here also, and it is suppose 70. So largest, this is the largest. Now the largest occurs here also, largest occur here also, and the largest occur in the leaf nodes. Means this is basically the array. All the array element is this. Okay, all the array element is this. Now check. I am sure that an element will be second largest only if it is compared with the largest. Is it possible that you are saying that this is the second largest, but you are not comparing with the largest one? You tell me.
Not possible, sir.
Not possible.
No,
That
sir, not
Not
possible.
possible, sir.
So that means whenever you are saying it is second largest, means east must have been compared at some point of time with the largest one. Now where the largest one occurs? Largest occurs here, largest occurs here, largest occurs here, largest occurs here. So that means the second largest element will be either say these one, or these one, or these one. Why? Because only means you see these one and these one are compared, these one and these one are compared, and these one and these one are compared. Other elements are not compared with the 100, means the largest element. Clear? So the second, so which element? What is the possibility that the second largest element will occur? Either here, or here, or here. Is it clear? So which elements need to be compared to find out the second largest?
So the yellow ones need to be compared among themselves.
Yes, fine. That means among these. Now tell me how many, what is the height of the tree?
So
Log n.
four.
No, here.
Okay. Sorry. Log in.
Okay, log n. This is the height of the tree
Hmm.
at most. Now height means that many levels are there. Okay.
Yes, sir.
And how many means what are the means how many such zero nodes, means the second largest elements may occur at this position. So how many such positions are there? Log n minus 1.
Yes, sir.
So at most these many comparisons, at most. Actually log n minus 2. But here you see first you have computed largest element by comparing how many times? N minus 1 times
Yes, sir.
largest one, and second largest actually log n minus 2, because these many nodes are there. You need to compare one element less n for n minus 1. So log n minus 1 for log n minus 2. Anyway, still I am taking this. So if I take like this, so what will be the sum? N plus log n minus 2.
Yes, sir.
So the, so which one is faster, this one or say if you design the previous algorithm to find the largest and second largest, means divide the array into two parts, find largest, second largest,
So this
largest,
is
second.
faster, sir.
This is faster because log n is faster than n by 2. You see the in previous case it was 3n by 2 minus 1. Basically 3n by 2 minus 1 minus 2 is sorry n by see, you see this portion, you check n plus n by 2 minus 2, and here it is n plus log n minus 2, n plus log n minus 2. So this log n is much faster than n by 2. Clear? So here I am not saying the time complexity is improved, but it is faster than the previous algorithm, because the time complexity is determined the largest power. Largest means this n.
Sir, why are we comparing time complexities of two different problems?
No, not different problem. I am saying that you can design the largest and second largest just like the previous one. That means I have not shown, but you can apply the same technique. Means this is the array. Okay, this is the array. Now you are dividing it. You find the largest. Sorry, you find the largest L1 or LA. This is A, this is B, and you find also the second largest, and second largest. Again, you may compare this. You need to compare, but I'm saying you can design, you can find out something like that, just like previous 3n by 2. But I am saying that instead of designing this, if I design like this, then the time complexity will be reduced. Is it clear? I have not explained that like the this one, because they are similar. These algorithm, that largest, second largest. Here largest, smallest, largest, second largest. It will be almost similar. So you will here also you will get 3n by 2 minus something. So 3n by 2 minus something. But if I, instead of doing that, if I apply like this, then it will be better. Is it clear?
Yes, sir.
Yes, sir.
And the last point for today's, you see that suppose in a graph, sorry, in a expression Tn is suppose n square plus say, this is say 4n square plus n cube plus n log n minus 5. So what will be the time complexity for this? Tell me. B go up,
N cube.
N cube, sir.
but suppose if it is so, say 4n square plus n cube plus which one is the larger? N cube log n. So if you draw a graph, means sorry, if you draw a graph, then you will get like this. Suppose this is x and this is y axis. This is basically function on n, and this is n. Okay. So if you take n, y is n, so you will get a curve like this. This is n curve, say. Then you will get an n square. Suppose you will get like n cube. You will get, say, 2 to the power n. So 2 to the power n means exponential, not polynomial. So any constant to the power n is exponential. C may be 2, 3, 4, whatever it may be. Or polynomial means n to the power k, some constant, k is constant. This is called polynomial. But don't say that you have designed an algorithm whose time complexity is big of n to the power 100. Nobody will accept it. Okay, try to design that is less than equal to n to the power 6. Generally n cube is better, means that depends on the problem, but there are few algorithms that for few problems for which the it may n to the power 5 or like that. So this, if this function is another thing, if a function, if tn involves, say, tn is 2 to the power n plus, say, factorial n plus n log n, say 5, say 10 into 2 to the power n. So what will be the time complexity for this? Please tell me.
Sir, n factorial.
Right.
N
Because
factorial, sir.
this is larger. Okay. Factorial n is larger than 2 to the power n. So here, or you may write like this also. Okay. So today I stop.
Sir, we write big of n power n, no, sir, for means we are taking